about reaching everybody, about innovation reaching everybody and coming back, and how do you access the talent of everybody? How do you make sure that internet reaches the far corners of the world? And once it does, how does great internet provide great services to people everywhere? What do networks, how do we build networks differently once they start reaching the far corners of the world, once they start providing video, once eventually, I guess, that 8K video, whether we think we need it or not, reaches our mobile devices. For this session, you're going to hear again from our Chief Technology Officer of Ericsson. You will hear from Mirantis, our guest from Silicon Valley. Naturally, innovation, Silicon Valley, kind of like peas in a pod. And then you will hear from Facebook Japan. In fact, the very first employee of Facebook Japan is here with us today. So look forward to that. Now, once again, Ulf Ericsson, our Chief Technology Officer.
Thank you, Dodi. Thank you very much. Yesterday, when we went through the session where we talked about business in transformation, we reflected on Ericsson's customers, the operators of the world, the service providers, making the move and the change from being very voice-centric business into the data-centric business. And you remember that there was some common denominators for those who were doing that change the best, something that we in Ericsson refer to as the growth codes. And the growth codes were based, and one of the single most important facts of the growth codes was that they were working very hard with performance of the networks.
An office in the wild. Or in the air. A bank transfer. From the tracks. An emergency update. On the road. A weather forecast. From the field. A shared experience. A container that talks to other containers. And an opponent in the other part of the world. That's what we call real performance.
This performance is driving the enhancements of networks worldwide. It's very recognized that this gives great results. There is also a very big difference between the different networks and how they perform over the world, something that you most likely experience as you're traveling into different networks and can see how well this has been focused on. So what can we then use all this for as we're moving? And now we're stretching it into the network society, the society that we're talking about here in Tokyo, where anything that can be connected and benefit from a connection will have one. We did in Ericsson research some work on that, and this one shows, for instance, just as an example, parameters like throughput, latency, quality of service, volume, coverage, capacity, security, and location, and how that will influence the different needs in that particular industry. These are just examples of parameters, but the networks can be built and done to perform differently on these parameters. And you can see here, and I will pick out a couple of these. We'll pick out cars and utilities and see how they influence by these different characteristics of the networks. The requirements then, and this is the key point really here, in the future will then come from these industries themselves. And we can just imagine that cars will contain music capabilities, film, navigation, and emergency services, and so on. We think that for each one of these industries, take the connected car, just providing the platform with the basics will also provide for new innovation, and we're just seeing the beginning of what each one of the industries can do once they receive the capabilities of networks to move forward. Let's take the utilities. Same thing here. It starts with just metering, perhaps. We heard yesterday also examples from both car industry and from the metering side, where new possibilities was provided by just reading the meters for the consumers, but also the possibilities to managing this in a completely new way for those who are producing electricity by using the same networks for being able for monitoring or for surveillance, for instance. So the networks of the future would have to in some way create a guaranteed performance for each one of these examples for each of the industries. If we plot that up and we look at the network of the future, that means that we could make a network that is sliced. Now we're introducing the term network slicing. And at the Broadband World Forum in Amsterdam, which was last week, we introduced and talked about network slicing and the connection between what we call service provider SDN technology and how we can really do this in reality. So this is the vision of the network moving forward, where dynamically we can set up a slice between a cloud where the services reside. It could be the Sony cloud, but it could be any cloud. It could be clouds for car industry or clouds for a particular car manufacturer if we follow the thought that they would go eventually to put their most valuable assets in their own clouds. Connecting that through the slices in the network to the capabilities of the devices. That's what we mean by the network slicing. So this can serve as a technology vision, if you will, for the network society. In Ericsson research, we have also come up with a simple model of how this future beyond 2020 kind of networks will interact. I will present that to you here. Quite simple. Devices, services, and networks and clouds will interact and put demands on each other. There are connections between the devices and the services themselves. That's what we call over the top. We have connections between the services in the clouds, in the sense that every enterprise are moving their services into the clouds. We have connections between the clouds and the networks, and here's the piece where we need to work more. Here's the piece where we can make the networks relevant to the clouds by putting software in the clouds that can find and use the assets of the networks, by exposing the assets of the networks to what's going on in the clouds. And then we have the connections, of course, between the devices and the networks, where obviously we need to standardize air interfaces, for instance, on mobile phones, to be able to get the scale of the industry and continue that scale. It's also important for us, given what I said this morning about the key trends, to be able to manage the complexity of all of this, to be able to secure that the security aspect is covered enough for people to put the trusts in using these kind of networks. You can imagine someone tampering with remote eye operations or tampering with remote car controls on the road. So the security aspect is one of the most important aspects if we're going to make this happen. And last but not least, the sustainability of this. Sustainability in two aspects. One, as a driving force for putting requirements on how we do this, and the energy consumption of networks is on the rise is one of the key things to think about. But also sustainability in terms of what our technology can provide in terms of building more sustainable cities where the networks will become the backbone of a sustainable city development. Now, when we are working with the network society, we also need to make some important redefinitions, and this is a little bit on the cool side of things perhaps, but we say we will need to redefine networks as they are. Today, Ericsson has very much defined the networks as our operators' networks. Now we redefine them as global networks, because the industry creating the future services is a global industry. And we already yesterday heard a question from Doug when he was asking Katie how he viewed the opportunity of global versus local, and how the global versus local problem is going to be solved as networks are local and as the internet is a global phenomenon with global service providers. So we're going to redefine the networks. We need to redefine the networks in terms of how deep they go into homes. Today the last mile, which is normally a Wi-Fi mile, the last meter I should say, which is normally a Wi-Fi meter, that is not, this network is not aware of what's going on there. There is no awareness in the network of that. So we introduce a term here, which I think you will hear more. Ericsson is famous for introducing new terms, such as headnet. But now we're introducing the term capillary networks. So capillary networks is when you go down to the smallest blood vessels into where the network is reaching, and it will reach deeper and deeper. We also need to understand that networks are the limit of new services, and that we talked about yesterday as well. We need to redefine devices as well. A wide range of devices, everything from Google's glasses to the wearables and the stuff that we talked to Sony about a few minutes ago. Those are the definition of devices. We have even gone as far in the machine-to-machine context to say that if you look at all the devices as the device volume, so to say, we can say that human usage is a special case. Sounds a bit scary, to be honest, but it will be. So it's a reality, and we need to cater for that when we think about the future networks. And the performance and experience is the limit of new services. So if we cannot achieve the performance that is necessary to remote control cars, the only thing that will happen is that nothing will happen, which is in itself it will just not happen. So, but at the same time as we raise the performance of the networks to live up to this, things will start to happen. And that's where the competitive edge will be for many other industries using our technologies to seek that border and always be pushing that border at the same time as the networks are developing. Sentient network, a new term. Sentient is a bit philosophical actually. It has to do in philosophy with using all your senses to build an image of the world, so hearing and seeing and so on. So in that sense, we're translating that into the network world, and we say that the networks of the future needs to be sentient. They need to use every capability to know what's really happening in them. They need to be self-aware, self-healing. They need to be always on. They need to be everywhere. We're moving from subscriptions to connections to sessions. I said that yesterday. And that is a very important journey. And each one of these sessions will instantaneously appear and disappear. And the network needs to be sentient about knowing what's going on there. And we need to do this with 5-9 security, as I said before, one of the absolute keys of the future networks. Here is a very simple model of what these future networks will look like. It's something that you will hear Ericsson talk about again and again. This is the horizontalization of the future networks. Here are the main capabilities, and if we start from the bottom, we see first and foremost the access networks, the core network, if you will, and the data centers. And these are data centers inside the operator domain and outside the operator domain. The global clouds, the infinite computing power and the infinite storage power that Sen-san also referred to. To be able to use this as one asset, we introduce virtualization. So virtualization of all the hardware assets in the different parts, which are today separated domains, but we now see as one asset. That virtualization is something then that the NFV Forum, for instance, is working on understanding and standardizing. Ericsson being one of the leaders in there to make sure that the architectural piece get right. We're focusing very much on the architecture in the NFV Forum. We have cross-domain orchestration, and we have an integrated control layer. Here is the integrated control layer. Traditionally, in the telecom industry, we have been very good at creating an integrated control layer. This is what telecoms has been built on from the beginning. We have been good at separating out gateway products. If you remember, in 3G we introduced the media gateways as one of the key developments. And we're now moving to use that kind of skills and competence that we have in this area to use that for creating an integrated control layer all across the network, from the access, IP transport into the clouds, introducing management and control. On top of that, then, we have the future development of the OSS systems in the world, where orchestration of these resources instantaneously based on information, real-time analytics of what's happening in the networks is one of the key developments. The orchestration will also be able to provide the simplicity that is needed in order for us to be able to expose some of the assets outside the networks. This is the key fundamental part of the service provider SDN architecture and idea. It is also the inspiration for Ericsson and where we focus our R&D and our resources. And I come back to the picture that we talked about yesterday, the areas of momentum. The heterogeneous networks where all the kinds of different accesses need to be orchestrated. The most scarce resource on the planet that we have is the spectrum. We need to make use of the spectrum in the best possible way, driving us to solutions in this area. For instance, what we did with the radio dot system, but also our other solutions that we're looking at in the radio arena, taking care of that frequency. Fourth generation IP, service-aware IP, it's IP networks that are able to identify and understand the kind of notions and what's happening inside the networks, becoming more and more important. And I think our focus of that during the last years on that, and many of you who have followed us knows that we've spent a lot of efforts and R&D and investments in that area. Those are paying off as the IP networks become more and more service aware and has to understand what's going on in the networks. And then last but not least, we have the OSS, BSS, and the big data focus, where we are using real-time analytics technology to be able to bring in what's going on in the networks and to be able to build that orchestration layer that I talked about before. In fact, it's interesting. If you reflect on high-tech development, you would see that a lot of what we're doing is taking care of implosion of technology. And what do I mean by that? It's basically that many technologies are imploding and we're creating new things in new dimensions out of the technology that is out there. I will give you some examples of that, but it is so that combinations, even when you look at Sony's presentation before, you can see how they are making use and combining photographic or imaging technology, for instance, with mobile phones. We have 4K and many other things happening. And in fact, there is a very close similarity to that, what's going on the consumer electronics side, what's going on also in the network side. Now we'll give a few examples of what we do in Ericsson. And I think the DOT, as you have seen, was a great change in the market and a big news when it came out, because it redefines the way that we do small cells. It redefines the market of indoor coverage. We make a new separation between the control plane, if you will, or what we call the schedulers and the baseband units in the radio arena and the radios. This is in fact just an amplifier, if you will, with an analog radio signal coming from the central piece of this with a small antenna on it, and you can even separate this so you can have different frequencies, which is on the thin disk here, which is separate. So this shows an implosion of technology, and it shows an innovation that Ericsson has done very recently. So I wanted to give you that example. I will also give you another example from the SSR family, our router side, where we are focusing on fourth generation IP. And we introduced very recently a processor, completely new processor called SMP4000. Here is the SMP4000, it's not super big. This processor is a 128K 1024 threads, which is computing threads, making it possible to program this in all 7 layers of the communication stack. In other words, you don't need to use machine code to reprogram this unit. Why is that important? That is important because we're able to make this instantly use service awareness. In other words, what's happening on top of the network can instantly be reprogrammed all the way down to the chip sitting in the actual routing inside the router. That is a good example of innovation power, and we introduced in Broman World Forum the 200 gig board into the routers that is going to be part of this family. This stuff is coming in the beginning of next year. But it was a practical example of what we are talking about in the new architectures that we're doing. The last one I just wanted to remind you about is what we introduced in Barcelona. If you remember, we introduced the Ericsson cloud system in Barcelona. Here is the NEP server, the hardware server in the NEP system that we are making for that, which is also soon to come out. So these are some examples of the implosion of technology, how we're able to combine things in a new way in order to meet the demands of this future architecture that we will use to build the network. All of this is then done with the notion of very high performance. We are going to see requirements of performance for all the reasons that I gave earlier to be one of the key aspects of this. It is important for all our industry to make sure now, with this kind of technology, that the networks stay very relevant. As the changes with the mobility, the broadband, and the cloud is happening, and more is coming into the clouds, we think that this industry sits on a key asset when it comes to making the networks very relevant. All clouds, where the infinite computing power and memory power has to be connected to devices out in the market. And let me finish up by this picture, which is really an Ericsson hieroglyphs. We have our own hieroglyphs, as you know. So if you read this right, you understand that the mobility, the clouds, the content creators, the networks, and the relevance of the networks is what's going to take us into the network society. Ladies and gentlemen, thank you for your attention.